From early Waterloo Boy to today's sophisticated Tier 4 PowerTech engines, John Deere has consistently embraced technological advancements while meeting stringent global emissions standards. With manufacturing facilities spanning the globe, from Waterloo to Pune, India, John Deere engines have become synonymous with reliability, powering everything from tractors to marine equipment. The story of John Deere engines is a testament to innovation and adaptation. Since producing its first diesel engine in 1949, Deere has continually pushed the boundaries of power and performance to meet the growing demands of agriculture, construction, and countless other industries worldwide. As farms expanded and implements grew heavier, the need for larger, more powerful engines became urgent. John Deere responded by increasing engine displacement, adapting newer technologies and advanced materials. This journey of engineering excellence underscores how John Deere engines have evolved to meet the challenges of the past, present, and future. Subscribe to the channel, and let's dive into the story briefly. The Dane all-wheel drive, Deere's first tractor with shift-on-the-fly transmission sold under the John Deere name, marked an early venture into tractor design. Initially powered by a Waukesha engine in 1915, it was later upgraded with a McVicker engine in 1917 for production. The real turning point came in 1918 with the purchase of the Waterloo Gasoline Engine Company, permanently embedding John Deere in the engine and tractor business. The Waterloo Boy tractor, powered by a two-cylinder gasoline engine with an open crankcase and a hand crank ignition. A simple carburetor mixed air and fuel for combustion, and cooling was managed through a thermosiphon system that required no pump, and the exhaust valve was mechanically operated, providing dependable power for the time. By the 1920s, John Deere realized that the existing Waterloo Boy engines were outdated. The company began incorporating significant improvements, introducing enclosed crankcases for better lubrication and durability. This marked the beginning of the two-cylinder engine era, a defining characteristic of John Deere tractors for decades. These engines used gravity-fed fueling systems, rudimentary air cooling or water jackets, and magneto-based ignition systems. The introduction of the Model D unstyled tractor in 1923 showcased this innovation. The Model D's production spanned 3 decades, becoming a staple in farming operations and one of John Deere's most celebrated designs. John Deere's innovation extended beyond tractors with the introduction of the engines like ED Series stationary engines in 1923. These engines were designed to provide dependable power for various agricultural and industrial applications. Initially available in 1.5 horsepower and 3 horsepower versions, the E-Series engines were prized for their simplicity and reliability. They featured a hit-and-miss governing system, ensuring efficient fuel use by firing only when necessary to maintain a consistent speed. In 1926, John Deere expanded the lineup with a larger 6-horsepower model, catering to more demanding tasks. These engines used magneto ignition systems in the later models, gravity-fed fueling, and water hopper cooling, making them versatile and easy to maintain. The E-Series engines became a staple on farms, powering everything from water pumps to grain mills, and they are still celebrated today as iconic examples of John Deere's early engineering excellence. In the early 1930s, John Deere's two-cylinder letter series engines marked a transformative era in agricultural engineering, showcasing significant advancements beyond basic increases in displacement and power. The engines from this era featured larger displacements, oil bath air filter, upgraded combustion chamber designs, and stronger materials, setting the stage for robust and adaptable machines that could meet a range of farming needs. A major innovation was the introduction of all-fuel two-cylinder engines in unstyled models like the A, B, and G. These engines were designed to run on multiple fuels, including gasoline, kerosene, and distillate. Farmers could start these engines on gasoline and switch to cheaper fuels, thanks to dual-fuel carburetors and enhanced combustion chamber designs. Improved cooling systems helped maintain optimal temperatures, even when burning heavier fuels. These horizontally opposed two-cylinder engines featured a unique firing order, producing a distinctive rhythmic putt-putt sound that became an iconic hallmark of the brand. Collectively, these engines are known as Johnny Poppers because of their characteristic pop-pop exhaust note, which resonated with farmers and enthusiasts alike, symbolizing John Deere's dependable and practical engineering during that era. The Model D, already iconic, saw significant increases in cylinder displacement, making it one of the most powerful two-cylinder engines of its time. In contrast, the introduction of the L and LA models catered to smaller farms. These engines were lightweight and compact, featuring integrated block and crankcase designs that reduced weight and simplified maintenance. High-compression gasoline engines in models like the H and M represented another leap forward. These engines delivered improved power and efficiency while reducing fuel consumption. Coupled with enhanced cooling systems in models like the G and M, these advancements allowed engines to perform reliably under sustained heavy loads without overheating, a critical factor for durability. The later years of this era also saw a shift toward operator convenience. Electric start systems became available on models such as the A, B, G, and M, moving away from the labor-intensive hand-cranked starters. The Model M, introduced in 1947, stood out as the first John Deere tractor equipped with an overhead valve engine, replacing the flathead designs of earlier models. This vertical two-cylinder engine featured a square bore-to-stroke ratio and 6-volt starting system and improved efficiency and power delivery. The M's creation was also a response to industry competition, particularly from Ford and Farmall's smaller tractors. Built in John Deere's new factory in Dubuque, Iowa, the Model M showcased the company's readiness to adapt to market demands and innovate on multiple fronts. In 1949, John Deere introduced its first diesel engine, which debuted in the groundbreaking Model R tractor. This engine was a major milestone, producing 51 horsepower and incorporating several innovative features. Central to its design was the use of two engines, a 6.8-liter, two-cylinder diesel engine as the primary power source and a smaller, two-cylinder, gasoline-fired starter engine, commonly referred to as the Pony engine. The Pony engine resolved common difficulties with starting diesel engines at the time. It could be electrically started via a 6-volt system, eliminating the need to manually turn the flywheel. Additionally, it preheated the diesel engine by channeling hot exhaust gases into the intake air and warming the engine block and head through a shared liquid cooling system. Despite its advanced features, such as a direct injection diesel system and a live power takeoff (PTO), with its own clutch, the Model R faced challenges. The thermosiphon cooling system and lack of a center main bearing on the crankshaft led to overheating and structural issues under heavy loads. Nevertheless, the Model R was a fuel efficiency leader of its time, boasting 45 drawbar horsepower and setting a benchmark for power and economy. Its success paved the way for future diesel-powered John Deere models, such as the 80, 820, and 830, which refined and improved upon this pioneering design. John Deere's two-cylinder engines of this period also incorporated substantial improvements in cooling and lubrication systems. The 20 Series and 30 Series tractors represented the culmination of decades of refinement. The introduction of diesel engines in models like the 720 and 820 was a game-changer. Larger radiators and more efficient water pumps prevented overheating during prolonged operations, while pressurized oil delivery ensured durability under heavy workloads. By the late 1950s, however, the limitations of the two-cylinder design were becoming apparent. While the distinctive thumping sound of these engines had its charm, the demand for smoother, more powerful, and versatile engines grew. The evolution of John Deere engines in the late 1950s and early 1960s marked a pivotal moment in the company's history as it transitioned from its iconic two-cylinder engines to multi-cylinder power plants. The announcement of this change came after 7 years of development and an investment of $40 million in retooling. In 1959, the rarest and four-wheel drive 8010 model showcased a 7.0-liter six-cylinder Detroit diesel engine, producing a groundbreaking 215 horsepower, an astonishing figure for its time. However, transmission issues led to the recall and conversion of most 8010s into 8020s, making the 8010 an interesting chapter in Deere's history. This period, marked by the new generation of tractors, represented a seismic shift in engine technology and agricultural machinery in general. John Deere introduced models like 1010, 2010, 3010, and 4010 in early 1960 as their inline-4 and 6-cylinder engines, and this have marked a new era. These models were followed by 5010, a tractor that became the first two-wheel drive to exceed 100 horsepower at the drawbar in 1962, solidifying Deere's position as an innovator in agricultural engine technology. The early 70s was also a significant milestone with the introduction of turbocharging, making the row crop 4520 tractor the John Deere's first turbocharged tractor. Advanced cooling systems with pressurized radiators and larger water pumps were introduced. Lubrication systems were upgraded to ensure consistent oil flow, increasing engine reliability under heavy loads. These engines, paired with advanced features like power shift transmission and modern hydraulics, not only powered the tractors, but also redefined what farmers could achieve in the field. These innovations reflected the increasing complexity and capability of agricultural machinery as a whole. The late 1970s and early 1980s ushered in the Iron Horses series, a line of tractors equipped with some of the most advanced engines of their time. Turbocharging became a standard feature, significantly boosting horsepower and torque. Models like the 4640 and 4840 showcased the power of these innovations, with the 7.6-liter engine delivering up to 180 horsepower. These six-cylinder engines were to handle extreme workloads, featuring direct injection, turbocharging, advanced cooling systems, and heavy-duty components for durability. At this time, the agricultural machinery industry was emphasizing fuel efficiency and power to support industrial-scale farming. To complement the increased power outputs, John Deere also focused on improved cooling systems. Radiators were redesigned with higher capacities and better airflow management, ensuring these engines could handle the heat generated by turbocharging and high workloads. Precise high-pressure direct injection in fuel delivery led to better combustion efficiency, reducing fuel consumption and emissions. The late 1980s and early 1990s brought a wave of innovation to John Deere engines, aligning with the industry's move toward larger, more powerful tractors to meet the demands of expanding agricultural operations. While many engines during this time were incremental upgrades, there were notable advancements in turbocharging, cooling, and fuel injection technologies, as well as an ambitious foray into V8 engine design. The 8850 stood apart as a bold experiment in John Deere's engineering history. This model featured a massive 15-liter V8 engine, the only V8 ever used in a John Deere tractor. With this engine, the 8850 delivered unparalleled power for its time, making it a favorite for heavy-duty tasks like large-scale tillage. However, the V8 design posed unique challenges. It was less reliable and more complex than the inline-six engines that were the mainstay of John Deere's lineup. This decision marked an intriguing but short-lived departure from the company's traditional engine designs. The period between the mid-1990s and early 2000s marked a transformative era for John Deere engines. It was a time when global emissions regulations, farmer demands for more efficient machinery, and precision farming spurred major innovations. In 1996, John Deere introduced a new generation of engines under the PowerTech name, designed specifically to meet Tier 1 emissions standards. These engines aim to achieve baseline levels for particulate matter and nitrogen oxides, or NOx, through several key innovations. A high-pressure fuel system was implemented to ensure more efficient combustion, while multiple aspirations and larger engine displacements improved power and torque output. The engines were also equipped with either 2- or 4-valve cylinder heads, further enhancing airflow and combustion efficiency. John Deere's 8070 series tractors, including models like the 8570, 8770, 8870, and 8970, brought significant upgrades to engine performance. The pinnacle of this series was the 8970, equipped with a massive 12.5-liter PowerTech engine featuring a dual turbocharging system. The sequential turbos provided a unique advantage. One turbo handled low RPM performance, while the second turbo kicked in at higher RPMs, delivering smooth and consistent power across a broader range. This innovation made the 8970 a standout choice for heavy-duty applications, where constant power and high torque were vital. By 2005, when Tier 3 regulations came into effect, and John Deere became the first manufacturer to widely commercialize cooled EGR and variable geometry turbocharger technologies for off-highway equipment. As the industry faced stricter regulations with interim Tier 4, John Deere introduced an exhaust filter system that included a diesel oxidation catalyst, or DOC, and a diesel particulate filter, or DPF, significantly reducing particulate emissions. To meet the even more challenging requirements of final Tier 4, the company developed an integrated emissions control system, combining the DOC, DPF, and selective catalytic reduction, SCR, technologies, ensuring their engines maintained high performance, efficiency, and reliability while meeting the most stringent environmental standards. Electronic unit injectors and high-pressure common rail fuel systems began to appear, offering finer control over fuel delivery and improved combustion. These advancements culminated in the engines powering the 9020 and 9030 series tractors, which pushed the boundaries of power, efficiency, and reliability. This video provides just a brief overview of the historical evolution of John Deere engines, leaving plenty more to explore in future deep dives. John Deere has also a long history of outsourcing engines from other manufacturers like Yanmar, Cummins, General Motors, and Detroit Diesel to complement its in-house designs and expand its product lineup. Subscribe to the channel if you are still here.